Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on formulas and units. This was a request by Hussein Shabazz, so if you have your own special request, make sure to leave a comment in one of my videos and tell me what it is exactly that you need help with. This is mostly about unit conversions and comparing, so we're going to go ahead and get started. This will give you a whole scenario, so it's talking about a formula n over a. You can read it if you would like. I'll leave it here. You can pause it if you need to. Essentially, the main parts of this is we need to compare these two things. So they're measuring bacteria density, and this first guy says that he has a density of 4,500 per square centimeter, and the second guy says 50 bacteria per square millimeter. And they're trying to figure out who has a higher density. Okay, so a bigger number. So what we can do here is we can compare. We're having the same units on top. This one's 4,500 bacteria over 1 square centimeter. And then over here we have 50 bacteria. And this is per square millimeter, so mm squared. Now, a couple things we need to consider. One, we could just simply look up the rate of unit conversion between centimeters squared and millimeters squared. You can't just do millimeters to centimeters. And the reason why is because it's squared. They're square units. So this is the unit conversion, but because they're squared, so if we square these ones, millimeter squared and centimeter squared, we get 1 centimeter squared equals 100 millimeters squared. That being said, if we wanted to get them into the same units, which we need to do if we're going to compare them, is we need to, like for example, I'm going to convert millimeters squared to centimeters squared. In order to do this, I need to multiply by my rate of conversion. My rate of conversion is this. So since I want it to be in centimeters squared, I'm going to put centimeters squared on the bottom. And I know 1 centimeter squared is equal to 100 millimeters squared. Therefore, I'm going to multiply 50 times 100 in the top. That gives me 5 with 3 zeros, 1, 2, 3, over centimeters squared in the bottom. Now I can get a better comparison. I can easily see that Orion, he was my guy, the second one in yellow, he has a higher density than my first guy does. So I can now, with confidence, say that Orion has a higher density because of those unit conversions. Okay, on to the second one. So in physics, work is defined as F times d, where F is the force applied over a distance of d. A box is dragged across 20 meters with a force of 60 newtons, which are kilograms times meters divided by second squared. What calculation will give us the work done in joules, which are kilograms times meters squared times second squared? Okay, so let's compare these two formulas. So if we already know newtons, okay, so those are our newtons, and we want to convert to joules, we have to compare our two formulas. So they're very similar. There's our Newton's formula. We have kilograms, okay, kilograms, check. We have second squared, okay, second squared, check. The only difference is this meter squared, okay? So the meter squared is the only thing different. And as you can see, we need to multiply by m to go from meters to meter squared. That's the only difference between newtons is joule, and joules is multiplying by m. So if we already have our newtons, and that's 60, and we want to convert it to joules, we would need to multiply by the distance, the 20 meters. So we need to multiply that by m, and here we know our m is in fact 20, so 60 times 20 should give us our joule. So it's just an understanding, this problem is just an understanding of what is the difference between these two formulas, and then applying the difference with the metrics that it gives us. So the metrics that it gives us is it has 20 meters. That's a known quantity for one of our variables, and we multiply by that known quantity. In this case is 20. So we're going to do 20 times 60, and that will give us our correct answer. Moving on to number 3. The formula for the distance traveled over time, t, and add average speed, v, is v times t. Okay. A meet ran for 40 minutes at a speed of about 5 kilometers per hour. What calculation will give us the estimated distance a meet ran in kilometers? Okay, so one of the first things that you're going to notice is it says per hour, and then it talks about minutes. So what we'll need to do is we'll need to convert this to hours. A couple ways to do that. Probably the best is doing 40 minutes per 60 minutes in an hour. And that will tell us what portion of an hour, and you're going to get 2/3 of an hour. Okay, so that's like 0.67 if you want to put in decimal form. So we ran for 2/3 of an hour at a speed of 5 kilometers. So you can do that, and that will give you your answer. So it's going to be like 10/3, and that will tell us our distance, because it tells us to find our distance, it's velocity. This is our velocity. We need to identify our variables here. So this blue is velocity, and then our time. Well, our time was this 40 minutes, but they're in different units. That's the main thing. We got to make sure we have all the same units. So right here, it looks like C. It gives us our 40 over 60. That's our time, times our velocity, which is 5. And that's going to be our answer, V times T. This matches here, V times T, correctly. This 1,000, I don't know why it's multiplying by 1,000. 40 times 60, you wouldn't multiply the two times together. And the other one is completely wrong. So C, 5 times 40 over 60, is our correct answer. All right, moving on to the last one. The formula for calculating wage is P over T, where T is the time duration for which an amount P of money is paid. Astrid is looking for a job at a call center. Call center A offers $15 per hour, and call center B offers 25 cents per minute. Okay, this is great. This is a very relevant problem here. Which place offers a higher wage? Again, we need the same units. They're offering 2 different units. This happens all the time, especially with companies and comparing prices for different products or services. So let's just break it down to A and then B. So A is easy because it's already done for us. We have dollars per hour. We just need B to match up. We have, let's change it to blue, 0.25, whoops, accidentally put a 0. We have 0.25 per minute. Okay, so I put 25 cents. I changed that to dollars instantly by just putting it 0.25. Hope you're up to speed with that. But we don't want minutes. We want hours in the bottom. Our goal is to have hour here, dollars on the top. So the one thing that we need to change is we need to change this minutes by canceling minutes on the top. So we know that there's 60 minutes in 1 hour. So that's what this is our unit conversion rate, unit conversion. So once we have our unit conversion, we are able to multiply the minutes, cancel, that's the whole point, and we're going to be left with hours in the bottom. But now we just do 0.25 times 60. You could also do 60 divided by 4, since there's 4 quarters in a dollar. Okay, 0.25 divided by 0.25 is the same thing as multiplying by 0.25 is the same thing as dividing by 4. And we know that it's 15. Okay, if you want, you can get a calculator, multiply 60 times 0.25. Trust me, you're going to get $15. And then we have per hour. So they're the exact same. They're the same job. So that won't be a differentiating factor. It will be the work for this person. So they're equal wages is the correct answer. So that's all there is to formulas and units. I hope you found this helpful. Again, if you have your own requests, make sure to make that known. And I look forward to seeing you next time right here on Wes Explains Best.